Okay, good morning. So we actually start the lesson. So still we are in combinatorics, but now we want to talk about the sum principle. Of course, these principles are so trivial in the first when you first encounter them, but you have to be sometimes careful. Okay, so and by the way, let me. Okay, so I've written here the sum rule or the sum principle. So if a first task can be performed in n sub 1 ways, while a second task can be performed in n sub 2 ways, and the two tasks cannot be performed simultaneously. So now this is being emphasized. In the previous case, the second one should be the number of the ways that you can do the second one should be independent of the first stage, something like that. But here, the two tasks cannot be performed simultaneously is important. Then performing either task can be accomplished in any one of n1 plus n2 ways, yes? The sum rule can naturally be extended to more than two tasks. That's also very clear. So is the content clear? So for example, if you're supposed to travel from Stockholm to another city, so you might be able to go with car, you might be able to go with plane. Assume that there are two roads taking you from Stockholm to another city by road, and then you have two airlines, for example, or three airlines that you can choose for. Okay, in how many ways you can reach to the other city? There is no way, this is meaningless to multiply them, yes? You can say that I have two options for if I want to choose a road, and I have three options if I want to, but when you go from Stockholm to that city, this is finished. There is no two-stage task. You just want to decide about which option to choose. And then you can say that, okay, I have two roads in front of me, three airlines, and I want to go from here, and that's it. So how many options are in front of me? There are 5 options. So I add these numbers together. Okay, but the problem is sometimes, this is my experience, even though you shouldn't get confused, but some people get confused sometimes which principle we are supposed to use, okay? So let me just start with some examples, okay? So there are 3 roads, exactly that is the same question. So there are 3 roads and 5 airways connecting 2 cities. In how many ways can one travel from one city to the other? So what's the answer? Yeah? 3 roads and 5 airways. So 8, yes? Is that right? That's it. Okay. So number 2. How many numbers with at most 4 digits can be written using 1, 2, 3, and 4? What if the repetition of digits is not allowed? Okay, that's also a very simple question. So I have 4 numbers, and I am supposed to write a number which is at most 4 digit. Okay, and then I want to solve the problem without any constraints and with the constraint that I'm not allowed to repeat any digit. Okay, so it's also simple, but not as trivial as the previous one. So how we should solve the problem here? So we have numbers 1, 2, 3, and 4. So these are the numbers involved for writing at most 4-digit number. Okay, so in your head you see that I can do it in completely different ways. Either I can choose a 1-digit number, or I decide to write a 2-digit number, which is not happening simultaneously if I choose the first 1-digit number. So these tasks, so you can imagine in your head, if this is the total possibilities that I have, I can break it, I can partition it into different categories. I can say that, okay, I have 1-digit numbers, I can count them, yes? Or if I like, I have to count 2-digit numbers, or 3-digit numbers, or at most what? Or 4-digit numbers, yes? And then one thing is important, they cannot happen simultaneously. So it means that if you decide to write a one-digit number, that number is no longer a two-digit number or a three-digit number. If you choose to write a three-digit number, it is always three-digit. It cannot be simultaneously two-digit and three digits. So this means that the whole possibilities in front of me is partitioned to disjoint parts. They don't have anything in common. So that is the important thing in the sum rule. So and then it means that if I count this part, if I count the number of items here separately, the ones here, the ones here, the ones here, every one, it is very trivial that for the total number of ways, I have to add these things up. Is that clear? So I ask myself how many one-digit number I can write without any constraints. Assume that you can use them as many as times that you like to. So how many of them I can use? How many four-digit numbers are there? Yes? 4. So I would say n1 is 4. But look, if I ask you how many two-digit numbers are there without any constraints, if you want, you can repeat them, but you are allowed to only use these digits. So in this case, you have to use a product rule. Is that clear? So it means this is a combination of product rule and the sum rule. So here, when I am counting this, I momentarily forget about everything else and I ask myself, I want a two-digit number. So this, for counting only this part, that part is a two-stage problem, yes? So I have to do it in two stages, a stage 1 and stage 2. How many ways I have to do a stage 1? 4. 4, and there is no constraint, so how many of them are there? 4. 4 again. So you see, but then the answer to this part only is just 16. So I have 16 two-digit numbers if I want to use them. And I hope that now you understand what the idea is. So I need to count this one. But for counting the number of three-digit numbers that I can construct with this without any constraints, I need the principle of a product principle. Yes, exactly the same thing. So I can imagine that for this task, for this part of this task, I have actually 3 stages. So 4, 4, and 4. Yes, so this becomes 64. And finally, for this part only, I have 4 stages. So S1, S2, so 4, 4, 4. Let us make it simple. Okay, so what's the answer? I have to multiply this by 4, so it is 256. So if I ask you what is 4, it means that you have 4 items here. If I ask you what is 16, you have 16 items here, 64 items here, and 256 items here, but your goal is to count all possibilities. It is very clear. You're not supposed to multiply, you are supposed to add, yes? So the question for the first part is actually 4 plus 16 plus 64 plus 256. So what is that? 80, 84, and that is 340 or something? Is that right? So it's 84, and then it's 260. I think it's right. Okay, is that clear? Now, if I want to answer the same question, but with constraint that I am not allowed to repeat any digit. The same problem, but with a constraint. So, do you think this will change? Number 4 is changed? The first one. No, because that's first digit. So I still have 4. But what is for the second one? For the second one, I want to write a 2-digit number using these numbers, and I am not allowed to repeat any digit. So what's that number? 4 times? 3. So you see, it's a combination of product rule and the sum rule. And the next one is 3-digit number. So 4 times 3 times 2. And the last one is 4 times 3 times 2 times 1. Yes? I'll have a 4-digit number. So this becomes 4 plus 12 plus, what is that? Is 24 plus 24. So it's 64. By the way, we can answer very highly non-trivial questions. It was not that hard. But the whole point is I want you to learn yourself when to use the product principle and when to use the sum rule. Okay, so let's go back here. So example 3, there are 5 red, 4 green, and 6 black different cars. In how many ways can one choose 2 cars of different colors? So I have 5 red cars, and I have mentioned the cars are different. So even if you have 5 red cars, they are different. So you can recognize the difference between them. So I have 5 red, 4 green, and 6 black cars. In how many ways can one choose 2 cars of different colors? So, I don't know, you need to start thinking. By the way, the best way to solve combinatorial problem is to think yourself in the position that you have rich enough to buy 2 cars simultaneously, and then you have these options in front of you. You can just make these stories in your head, okay? And then what happens? You really want to choose. It is a simple task. It is not possible to imagine that there is a person cannot do that. Yes, if you have enough money, of course. Yes. Okay. So if you can do that, it means in principle you should also be able to count the number of possibilities. So how should you do that? Okay. So you analyze the problem. So I have how many red cars? 5. So I would call them, for example, red number 1 up to red number 5. And then how many green cars we have? Green number 1 up to green number 4. Yeah. And then the black cars are 6. So black number 1, black number 6. My point is to do what? Is to choose 2 cars of different colors. So how do you solve the problem? In how many ways I can choose 2 cars of different colors? Yes?
Maybe if you start separating by which combinations the colors can be. So
exactly.
It's red and green.
Yeah, so that's the way that we have to think, yes? Because I can consider 3 scenarios here. Either I choose red and green, yes, so red, green, let me write like this. For some reason I like this combination. Or I choose red, black, or I choose what? Green, black. Okay? So here the order doesn't matter at all because this is just a combination of the colors that I like. So it doesn't matter if I say green, red, or red, green, doesn't matter, yes? Okay, but if you choose a red and green car, can you also simultaneously choose a red and black car? No, this does not happen. If this occurs, it means that this and that will not occur. And if this occurs, this is important for the sum rule. They cannot happen simultaneously. Okay, so this means that in your head, this is the possibilities that you have for the combination of colors. Okay, and then you start counting them. Okay, I want to know how many choices I have if I have already made my mind to choose a red and a green car. Yes, for choosing a red and a green car, I am facing a 2-stage problem. Yes, I have to choose a car from red ones, I have to choose a car from green ones. So I can break it into 2 stages in my head, yes? So it doesn't matter, I think, hopefully you agree that it doesn't matter. Stage number 1, choosing a red car, stage number 2, choosing a green car, or the other way around. For choosing the red car, how many options I have? 5. And for choosing the green car, I have 4. So this means that the number of items here is 20. By the way, you need to think all the things. Is this number 4 independent of my choice here? Yes, it doesn't matter which car I choose. From the red ones, I still have 4 choices for the green one, yes? And I think now everything becomes clear for you. So what is the number of items in RB?
30.
Yes, R, how many choices I have? 5, so let me make it simple. 5 times 6, And then how many items I have here? 4 and 6. And then, okay, now I have these numbers in my hand. What I'm supposed with these numbers? What I'm supposed to do with these numbers? Add them. So it is clear. If you just analyze the problem in the correct way, it's not confusing at all. Yes? It is 74 ways. For example, they might ask the question in a probabilistic way. For example, they can say that, okay, a person has chosen 2 cars from these cars. What is the probability of the chosen car to be red and green? So they can ask the question in this way. Yes? Okay. In that case, I have to calculate the total number of possibilities, which is 24. But I am interested in the choices for red and green. I already know the total number of is 20. So the chance of this has happened is 20 out of 74. So the probability is 20 over 74. I have seen questions of probability being asked in the book itself, okay? So you can just design the questions in that way. So that's also very simple. But I mean, you have to analyze the problem a little bit. Okay, let me go back here. This one, I want to wait for you before I solve it. Okay, how many 3-digit even numbers can be written if repetition of digits is not allowed? I want to wait a little bit for you to see how you think about this problem. The reason I am waiting for you, because we solved some of these type of problems before, yes? I think there is a reason that I put it after the sum rule. I want you to really analyze the problem. Do you really need the product rule and the sum rule here? Or is it possible to solve it just with the product rule? Because if it is possible to solve it just with the product rule, I consider it superior to solve it into, because when you want to use the sum rule, you have to start dividing the problem into smaller pieces. But if you can solve the problem in one go, of course, if you divide it, you will also get the correct answer at the end, if you do it correctly. But of course, if you can do it with just one principle in one line, it is better to divide the problem into pieces. So this is the why. I don't want you to just solve the problem. I want you to think about it. Is it possible, first of all, to solve this problem just using the product rule? Because it is very similar to the problems before this lesson. And if not, I want you to understand why it is not and then solve it. So that's what I want you to think. I just give you 5 minutes. It's not hard, but I want you to analyze the problem. So how do you analyze the problem? Could you solve it just using the product principle?
I think so.
Is it possible? Okay, let us see. So the digits that are involved, of course, are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes? And then I want to write a 3-digit even number without repeating digits. So it means that I have a 3-stage task. So stage 1, or I don't know, if you prefer any kind of order. So let me just, because I have 3 digits, so I can break it down into 3 stages. Okay. If you want to write it with the product rule or product principle, okay, which one do you want to choose as stage 1? Because you said it is possible, yes? So what should I do?
The last digit.
The last, you mean this one?
No.
No, this one. So you call this a stage 1 and a stage 2?
It doesn't matter.
It doesn't matter. So let me just take this and then take this. If you say it doesn't matter, okay? So how many options I have for S1?
5.
0, because I want to make it even. 0, 2, 4, 6, 8, 5. Okay. Then I go to stage 2. I'm not allowed to repeat anything. So how many options are available? Because I'm not allowed to repeat, you are right. One of them is gone. Yes? So one of them is gone. For example, 8 is gone. And how many options are left for S2? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 9 options here. Another one is gone. For example, 9 is also gone. How many options are left? 1, 2, 3, 8. Yes? 1, 2, 3, 4, 5, 6, 7, 8. So can I write 8 independent of my choices here?
You can't write 0.
Yeah. So it is clear we cannot do that. Yes? Because it might happen that I have chosen 0 here. Then how many options I have? I have 7. But if I haven't chosen 0 here, I cannot choose it here. So I have only, how many options?
7.
So let me just repeat it again. So might be, this is my choice. Let me say, when you say 5, I hope that you agree that one possibility is to do this. Let me cross this over. This is gone.
Baba, S1 can't be 5.
Pardon?
S1 can't be 5. It's not the
No. This is the number of ways. Yes? So this is the number of ways I can do that. Okay, so the number of ways, you say 5. One of my choices is to put 0 there, yes? And then when you come here, you say that I cannot choose 0, you are right. I have 9 options in front of me. I take one of them again off. And how many options I have? 1, 2, 3, 4, 5, 6, 7, 8. Yes? But if I haven't chosen 0 here, assume that I have chosen 2 here, then 2 is gone. Yes? And then I choose 1 for this one. And then I want to write this one. Still, can I write 8? No, because I not only cannot write these two, but because this is the leftmost digit, I cannot choose 0. So it is not 8. So it depends to your choices in the beginning. Yes? So at least it is hopefully clear for you. That was okay, I could do it without any doubts. I also could do it without any doubts. But when I come here, it depends to my choices in the previous cases. They differ by 1. Yes? So this is not possible. Is that clear? Yes or no, Hussein? Why is not?
because the last digit, S3, it can't be 0.
I'm just telling you exactly this. So it means that you cannot choose 0 here. So the number of options is less. But when you say 5, it means that you might have chosen 0 here, and there is no 0 left. But it might happen that you have chosen 2 here, then because you cannot choose 0 here, this number is not the same. I don't know how to explain more, because this number that I put here depends on how I have done the first and the second stages. Whenever this happens, we cannot actually use the product principle directly. But by the experience you had before, you might say that, okay, let us rearrange the stages.
Yeah, I was thinking, can you not take the first one as S2 and the...
Okay, so let me just, this didn't work. Yes? Let me just do this the other way around. So, okay, so what is you are telling Zohar? So what should I do? Which one?
S2, S3, S1.
So S1 is what? Which one?
The one to the right.
Yes, this is S1.
And then S3. First, like in the middle, S3.
In the middle is 3.
Yeah, and then S2.
Okay. So you might think that this will work. Let us check that one again. Okay, if you didn't understand the previous one, please listen again here. Okay, if I ask you how many options I have for stage 1, I know that I want to make an even number. I know that I am not allowed to repeat. So how many options I have here? 5. Yes? Okay, when I write 5 here, then according to Zohar, I need to jump here. This is the second stage. How many options I can put here? This is important. The number that I have to put here should be a certain particular number. If it depends to this, the product rule is not applicable. So how many options I have here? I hope that you agree. Again, it depends.
Yeah.
Yes? Do you agree or not?
Yes.
Because it might happen that I have chosen 0 here. So 0 is gone. How many options are available here? 9. So I should write 9. Yes, but there is no guarantee that I have chosen 0 here. It might happen that I have chosen 2 here. Then 0 is not gone, 2 is gone.
Then you cannot.
But then I want to write a number here. How many options I have now?
8.
8, because I know that I cannot choose 0. So you see, this is or 9 or 8. So this arrangement didn't work. This arrangement also doesn't work. So it means the product principle in its own is not probably enough, or might be, if you want, you can change another order. But it doesn't work, you can trust me. You can play around with the orders, it will not work. Oh, that is, I just want you to tell you, because solving this problem, even though it's very similar to the previous problems, we cannot solve it. Let me just ask you one question before solving the problem. If the constraint of not having repeated digits is released or relaxed, do you think I can solve it with the product principle? I want to have even, but I do not have the constraint of not repeating things. Can I solve it with one principle, product principle? Let us just do it in a scratch word, okay? Because that's not the problem itself. But let me just try to understand this part. Because still, you see, even though what I told you understood at the spot, but sometimes you don't respect it that much. I want you to see, you really have to be careful all the time that the number that you put here does not depend on the previous ones. This is extremely important. If you don't respect that, then of course you will have troubles. Okay, so let us try to solve the same problem, but only I am allowed this time to repeat the digits. Okay? Okay, let us see, is the product principle enough to solve that problem? I hope that you agree again. I will start with this one here, and I put S2 here, and then I put S3 here. Okay, let us see if it works or not. So now tell me, how many options are available here? Still 5, okay? But then I jump here. How many options are available here?
9.
I do not have the constraint. I can repeat things this time. I have 9. Is this 9 depending on how I did this one? This time, no. For example, you might have chosen 0 here. Okay? Okay. Here you cannot choose 0. How many options are available? 9. But assume that you haven't chosen 0 here. Might be you have chosen 2 here. But when I want to count this, how many options are available? Still 9, because I can repeat what I have done before. So this is still 9. There is no doubt 9 or 8. And then how many options are available here?
9.
How many options?
9, yeah.
No. How many options are available here? 10. 0 can also be chosen this time. So then this becomes 450. 450 this time. So you see, if I change the problem slightly, now the product principle in its own is enough, but not for that problem. Okay? Is that clear? Okay, so this was enough. That is the correct answer for the number of 3-digit numbers. By the way, it's reasonable, because how many 3-digit numbers are there? 900. And if I don't have any constraints, half of them are even, half of them are odd, so it becomes 450. So that's reasonable. Okay? But this one is not possible. So we actually discussed 2 kinds of arrangements for stages. None of them will work. You can, if you don't trust me, you can try it the other way around. It will not work. So this means that the product principle in its own is not enough. Okay? So whenever this happens, this is the rule of thumb. Whenever you have this or somewhere coming in, it means that you need to use the sum rule as well. Because you say, oh, this one, or if not this one, that one. Then I count them and I add them. Okay? So, how can you divide the problem now? So, this is the question. This is the total number of items. Imagine like this. This is the total number of 3-digit numbers which are both even and they do not have repeated digits. You can partition them into different pieces and count each part individually. So how do you partition? Of course, you can partition too much But don't do that. Yes? Try to partition as few as possible, as few parts as possible. Yes? How do you partition?
I'm not sure if this is the most optimal way, but I would partition it into the numbers that don't have any zeros at all.
Yeah.
The ones that have a zero in S1, and the ones that have a zero in S3.
Yes, it will work, but that's not optimal. You don't need to subdivide to 3 categories. Any other suggestions? Yes?
Numbers which have zeros in it, numbers that don't.
No, it's not precise. Because I want to have also even numbers.
Yeah.
No, because by the way, what is the bad point about partitioning in that way? Because, for example, what do you think about 104? So if you partition them, because there are some even ones also including 0. If you're partitioning in that way, you're excluding one of these. Do you understand what I mean? Because you told me I partitioned the numbers. I want you to understand this. If you partition the numbers into 2 pieces, one pieces which contain 0 and one piece which does not contain 0, then there is no way for you to count 104, which is acceptable. Yes? Because 104 is not only even, but also includes 0. Yes? Am I right? You can count this one as well. But the way that I partition it in my head, I partition the even numbers into 2 categories. I would say that the unit digit is non-zero or the unit digit is 0. Okay, so what I do, I would say that, okay, the units digit is 0. The units digit is non-zero. That is enough, I think, yes, because if you have an even number, there are only 2 possibilities for you. Either the right-hand side digit is 0 or non-zero, and they don't overlap. Do you agree? Because if you write a number whose unit digit is 0, it cannot simultaneously be here. And if you choose a number whose unit digit is non-zero, it cannot be here. So that is extremely important. For the sum rule, you have to check that they don't overlap. For the principle of product, you need to check that they are independent. Okay? So, but of course, I am not talking about. I'm just summarizing. My goal is still to write. If you want, let me write it properly. Okay? So this rectangle, the total 3-digit even numbers with distinct digits. This is the way that you have to think, okay? But there are 2 types of these type of numbers. One partition, you don't need even to care about the size, but it is clear the size of this one is smaller. So, units digit is 0. Is 0. The units digit is what? Non-zero in this case means what? The units digit is non-zero and even. So it means 2, 4, 6, 8. Yes? 2, 4, 6, or 8. I really don't want you to write all these things, but this is the way I really think, even though I don't write it down. Okay? So this combinatorial problem are of this nature. If you want to do it quickly, it will not work, even though the answer is just one single number. Okay? So now, help me to do these things separately. The thing that you need to respect is that there is no overlap between this part and that part. This is important. Okay, now, can you help me to solve that problem? For solving this part only, I need the product principle again. But you see that this doubt will not happen anymore. So I would say stages. Oh, it's okay. But you still have enough experience. So when I say the unit digit is 0, so let me call this stage 1, stage 2, stage 3. For example, how many options are in stage 1? 1. Because I myself told this is 0. So how many options I have here? 1. Don't get confused. This is the number of options I write, always. But what is the option itself? Is 0. Yes? Okay, now remember, repetition is not allowed. 0 is used here, so I have to drop it from my list. So there's no zeros anymore. And then I go to S2. How many options I have?
9.
I have all of them, 9. And one of them is gone. Which one I don't know. But how many options are left?
8.
Is this 8 independent of what I have chosen the previous one? Yes, so I would write 8. Is that clear? Okay, and then I multiply them, so it becomes 72. If I ask you to write something in front of 72, you will tell me there are 72 3-digit even numbers with distinct digits where the units digit is 0. That's the meaning of this 72. Yes? Okay, but this is not the only possibility because I have another possibility. How many stages I have again for this part?
3.
Because the goal hasn't changed, there's still 3. Which one you take by experience as a stage 1?
Third one.
Yes, a stage 1, and then a stage 2 has also some limitations, and a stage 3. Okay, let us not get confused here. So how many options are S1 if I am counting these? 4, 2, 4, 6, or 8. So I have 4 options available. One of them is gone, because I'm not allowed to repeat. For example, but this is important to check it is independent. For example, for simplicity, let us take 2 out. Yes? And then I want to go here. How many options I have?
8.
I have 8, because I cannot choose 2. I know that I cannot choose 0 either, yes? So how many options are left? 1, 2, 3, 4, 5, 6, 7, 8. So here is 8, but writing this 8 you have to be careful. Is it independent of the way that I did the first stage? For example, instead of choosing 2, let us this time choose 4. Do you think this will change? No. But still I have 8. So this means that this is independent. Okay? And now, tell me how many options are there?
7.
Be careful.
9.
But this is simple.
We can all of them.
No, repetition is still not allowed.
9.
So, how many options I had here? 4. One of them on this list is gone. So if you don't mind, let me just clean that. For example, 2 is gone. But how many options are available here? Because I know 0 cannot be chosen here, so I choose one of them, and that is gone. Yes? So for example, let us take this one out. But then I come in the middle one. Which one of them I can choose here? All of them. And then I count them. 1, 2, 3, 4, 5, 6, 7, 8. That's 8. Yes? And then what's the answer? 256. And then what should I do? What is the final answer? We have to add them now. So I need the sum rule, yes? So 72 plus 256. So the answer is 8. And then 2, 3. By the way, I don't know if you are quick in programming things. Is there anyone can check this directly by writing a code? But I just want you to understand that this is not a number that it is trivial. Even though the problem is extremely simple, but if I just ask you to guess or to do, reaching to this exact number is not that easy. I hope that you agree. Even though this problem in its nature is extremely simple, But without writing all of them down, we were able to answer that. So if you are experienced, you can count things very efficiently without sitting and writing and counting. Yes? But one way to do that is, it's very good practice, by the way. Write a code in any language that you know, so that generate all these numbers, put it in a list and count the length of that list. If you have done everything right, the answer should be 328. Is that clear? Okay, so you see, this is a very simple example, but it actually highlights a lot of important points. So for example, you realize that, okay, this is strategy of reordering. Do you remember I had some examples that this strategy worked? But in this case, this strategy does not work. So this means that I need something more. And then we realize that we can combine these two and then solve the problem. Is that clear? Okay. Let us see how much experience you have now. Okay. So that's it. That's the lesson. But the rest of it you need to think. And I just tell you that these problems could be extremely hard. And the unfortunate thing is that if you get 327, you get completely zero. It's not correct, because it might happen that you have a wrong strategy that has given rise to 327. Okay, so the answer should be exactly, and that is black and white. That is the only answer. Okay. Okay, so let us go back here, and I want to wait for you, because I think I would say that this is not that hard, so I want to wait for you. So let me just read that. How many 3-digit numbers are there so that each of them contains exactly 15? Okay, I want to wait for you. It's a very simple question. Okay, so might be this is the one which is the hardest one. By the way, it's non-trivial, yes? How many 4-digit numbers greater than 4,721 with distinct digits are there? Okay, so the problem is very clear. We want to write a 4-digit number which is greater than 4,721, and we are not allowed to repeat any digits in the numbers that we want to write. Yes? So that's also good if you can just write a code to generate all of them and then count them and compare them with the answer that we are supposed to get. But I want to wait for you, okay? Could you solve the problem, or at least have a strategy for that? This is a little bit, we have to be careful. So we want to find all 4-digit numbers. So let me write the digits we have. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, yes. And the number is 4,721. So we want to see how many 4-digit numbers are there greater than this one. This up to here is extremely simple, yes. If I just ask you how many numbers are 4-digit and greater than that one, that's extremely simple to answer. But the point is that I don't want to have repeated digits. So I don't know, how did you think about the problem? Because there is no thing that I can teach you. You need to start working things around if it works or not. There are some things that I can highlight here, but this is the nature of these kinds of problems. And if you solve this problem, there is no guarantee you solve the next one. They are totally different. Yes? That's the nature. In Math 4, when you learn to differentiate something, you can play around and differentiate a lot of functions. Yes? But here, no. There is no guarantee that you can solve the next problem. Okay? So this is what it makes this branch of mathematics, discrete mathematics, hard. Okay, so how can I... What is your strategy? You need to have a strategy. Any ideas? Yes?
Maybe we could count the combinations up to 4,721 and the ones beyond that, and we could like subtract it from the total.
No, but it is not working because we want exact numbers. Yes, we want to have a strategy that it works. Yes.
Maybe like write digits greater than 4 and then digits greater than 7.
This seems good.
Yeah.
So because if the left digit is 5, 6, 7, and 8, I really don't need to be worried at all, yes? So I would say that, okay, so let me just write, if I want to understand the problem, I will always draw this picture. So here I would say that the left digit, so let me just do it like this. So I don't know, so I put something greater than 4 here. Yes? If I put something greater than 4 on the left digit, I don't need to be worried at all, yes? Because definitely it becomes greater than this particular number. So I would say that, let me write, I don't know how to write, so I would say that, let me just show it by diagram, okay? So I have this 4 digits. Assume that this is greater than or equal to 5. That is one possibility. Yes? Counting them isn't hard. Let us count it immediately. I want to see how many 4-digit numbers start with 5 or beyond 5. If I just count all of them are guaranteed to be greater than this one. So I don't need to be worried about that extra constraint. Yes? Just I need to focus on counting these so that there are no repeated digits. Okay. What happens? How many options I have for this stage? 5 and high. So 1, 2, 3, 4, and 5. Yes? So I have 5 options available here. Yes? Yeah, you have to help me because I might get confused. If I'm confused, you can help me as well. So I put a number 5, 6, 7, 8, or 9 here, so I have 5 options. Agree? But one of them is gone. Yes, because I am not allowed to repeat the digit. Okay, so say for example 6 is gone. And then I go to the next one. How many options I have? 1, 2, 3, 9. Yes? I have 9 options here. Agree? Is this 9 depends what is my choice here? No. Yes, I could have chosen 8 in the first stage, but still I have 9 left. This is you have to check. Okay, now 2 of them are gone. One from this list is gone, and I don't know, one from the other list is gone. So I have only 8 left. And then another one is gone. So how many is left? 7. Okay, can you? So what is this number? 5 times 8, 40, and 360, 2010. Yeah. So 2100 and.
Yeah.
Is that right? Okay. So that is the answer. And then we go. The next one you have to be careful. So can you tell me what is the next category? Because do you agree that first of all I didn't consider all of them? I considered the majority of them. But still, there are some numbers that I didn't consider. For example, can you give me an example of a number which I didn't count in this part? Yes?
4,722.
No, 22 is not in my list. Because 22 is repeating 2.
Sorry, 23.
23. 4,723 I didn't count.
Yeah.
But it is acceptable. Yes? Because it has 4 digits without repetition and is still greater than this one. So it is clear that I am not counting all possibilities, even though I counted the majority of them. Yes? Okay, so now help me to write something for the next part. What should I write for the first part? Which ones I haven't counted yet? The ones that start with 4. Yes, so I would say that, okay, let me put 4 here. I just put 4 here. And then there are 3 more digits coming. But here, how many options I have? 1, because I put myself 4 there. But 4 is now gone. Because I'm not allowed to repeat it anymore. Okay. But can I say that I am completely free now? because I want to have a number greater than that one. So I'm not completely free to choose the next one. Because if I accidentally choose 6 for the next one, yes, it doesn't work. I want, okay, so then that's problem, what should I do then? So I would say that, okay, let me put 4 here. Let me put a number greater than or equal to 8 here. And then I am free after that. Yes? Okay, so for this one I have 1. Be careful, 4 is gone. And I have to choose a number 8 or 9. That is the only option I can choose for this one. So how many options I have? I have 2. But remember, one of these numbers greater than or equal to 8 is also gone now. So for example, assume that 9 is gone. How many options are available? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 options available here. 1 more is gone, 7 is left. Am I right or not? So what is the answer to this one? Is what? 16 and then 70. Yeah, 112 I think, yes? Okay, so that's 112. But still, it is not the whole thing, yes? Because there are some numbers that I haven't counted yet. Yes? For example, which number I didn't count yet?
4,731.
Yes. So the ones that starts with 4 and then the next one is 7, but it's still, so it means that the next one is more natural. So I will go here, here, here and there. I choose 4 here.
7.
I choose 7 here. And then I start talking about the next 2. Okay? So be careful. 4 and 7 are gone. So let me clean them and then put them back again. So 4 and 7 are gone. So I would say 1 times 1. 4 and 7. Okay. I want to come from here. So I choose this number what? Greater than or equal to 3. Okay, but be careful. When I say greater than or equal to 3, I start from here. When I go up, 2 of them are gone. So you have to be careful about not missing things. So 3 is acceptable, but 4 is gone. So 3, 1, 2, 3, 4, 5. So there are 5 options left. Okay? But one of them is also gone. And then how many options are left for this one? 1, 2, 3, 4, 5, 6, 7. Which is 35. Yes? And then finally, there is still a number that I haven't considered yet. Yes? Is that right? Okay. So now what should I do for the next one? Can you tell me?
The first 3 numbers are the same.
Yeah, exactly. So 4 is here. 7 is here. 3 is also here. So let me write them back. No, 4 is shouldn't be. So let me write 4, 5, 6, 7. Okay, 4 is here, so 4 is gone. 7 is here, 7 is gone. 3 is here, 3 is gone.
Why did you put 3?
That's the same. It's because even if I put 3, then I haven't counted all the numbers. I want to.
Shouldn't you put 2?
Exactly. Why did
Yes, might be. Yes, you're right. Yes, thank you very much. Thank you. That is 2. So sorry. So 3 is there, 2 is gone.
It's okay.
Yes. So one option, 4, 7, 2. And then I want to put a number what? Greater than 1. But greater than 1 from the list which is left. Greater than 1, this is not greater than 1, this is not greater than 1. The greater than ones, the greater than 1 that are left are 1, 2, 3, 4, 5. Yes? So the number of those numbers is 5. And I hope that you need to confirm that. Do you think there is any overlap between them?
0.
Is it possible that I am counting things 2 times?
No.
No. Because the numbers that I put here start with a 5 or greater. The numbers that I put here start with a 4. So there is no overlap. And the numbers here start with a 4 and the next number is 7. But the numbers here start with a 4, but the second number is greater than or equal to 8. So I hope that you convince yourself that I haven't counted things 2 times. So that's the only possible thing. So what is that? It is 40, 152, yes. And I add 152 here, 152, 7. what is that? 6. Yes, so that is probably this number. Yeah, but of course, always there is a risk of making things wrong. That's why I'm saying that it is a very good thing. You should be able to write. Who can write a code for this? Yeah, I can do that, but I do not have the compiler for the program that I use here. But it is a good practice, by the way. Can you see? You can generate this by programming. You should be good in these things. The technique students I'm talking, yes? So you should be able to write a code that generates all the numbers in my list and then count them. That is actually very simple. Okay, any questions? Thank you very much.